start recording this. Sorry, I'm really not on top of my game today. It was kind of a really messy weekend. So, and okay, I will fix that. Weird. Okay. Okay, let me go ahead and try to fix that. Okay. I will fix that after the exam. So, because I seem to be having issues with this and I want to make sure I get to everything. So, questions for this. This kind of question will be on the, this kind of question will most likely be on the exam where I'll want you to draw something. For that, you can either draw it on your computer and like draw and upload a PNG for that one, or you can, draw it, take a picture with your phone and upload it that way. I'm pretty agnostic. But do whatever makes sense for you. So using a linked list with 3 nodes, draw what happens as each line executes. So, and we kind of did that already with the drawing that I had, but as I was working on it, because drawing and linked lists kind of go together hand in hand. So so first thing's going to happen is do tail.next. Tail is equal to tail.previous, so that will move over here. And then we will, so I'll say like 1, move this tail to there, and then 2, delete that. It's messy here, but again, I'm working on a computer. So,
so for a doubly linked list, as soon as you make like the new tail.next equal to null, you don't have to worry about the original tails like dot previous. It's just all gone.
It will all be gone because there's nothing referring to it.
Okay, cool.
That's what matters there. Things referring to it. So write a sequence of commands using that will add index 0 to a doubly linked list. Right. So that one, it would be just simply, let's go with add index 0 to a doubly linked list. Okay. So what we need to do is basically say we've got this new node. So new item. So first thing we need to do is make a new node. So node n is equal to, and notice here, I don't even care about generics because I'm just trying to be quick here. If you forget generics during the exam, guess what my response is going to be? Auto failure? No, I'm just not going to care. Okay, new node, item. I understand that basically you're going to be working quickly. So node n, so first thing I'll need to do, right? Right, so first thing we got to do here is 1, I'm going to, let me go ahead and actually do this like this, or rather, I think I know how I want to do this. So first thing I'm going to do is I'm going to say, hey, item, that's step 1. Step 2, what we're going to do is we're going to connect it. So I'm going to use these lines, dashed lines, to show kind of like I'm drawing that. Step 2 is basically I got to connect that sucker to what's currently the head. Okay. So n.next is equal to head. Then we want head dot, what's the current head dot previous is equal to n, right? 3. And then the last thing we need to do is head is equal to n. And what we'll do over there is I'll just simply say, hey, step 4, have head point to that. If you flip head is equal to n, yes. So the thing about doubly linked lists is that flipping the order, you can flip the order for next and previous a lot of the time. But for singly linked lists, it's a lot more strict. There's a trade-off. Like there's more lines for doubly linked lists, but but there's more right ways to do it. Yes, because, well, head always has a previous. It just happened to be null, right? So, okay. So suppose you have some list of integers. Write a method that finds minimum and maximum values in the list and returns their sums regardless of the implementation of the list. So this one is where I'm going to, so this one is actually, the code is easy here. The big O analysis is where I'm going to get you. Okay. Because that actually matters a whole lot based on your assumptions here. So if you want to show off and get extra credit points, you can here, because first off, because it does not say that. So just useful notes over here. You're allowed to clarify any answer you give, and all questions are essay questions, including the multiple choice, which means that you can always argue that your answer is correct. Extra credit is available for exceptional answers. Okay. So let's go ahead and do new Java class. List stuff. All right. Yeah, that's totally melting. So let's see. I'm going to be quick and copy paste this, right? Okay. And part of this starting off of here was just to make sure, was to deal with an error that I would often get from students, which is correctly setting the minimum and maximum values in such a way that we'd be able to see what they are. So I set the minimum value to be the biggest number. So anything I find will be smaller than it, right? And I set the maximum, the initial value for maximum to be the smallest possible value, so that anything I find will be bigger than it. So and that's so and the reason I did that is that I didn't want to I'll remind you to use get there. Okay. Return min plus max. So we're going to do this in two ways. Okay. So first way is the way you're more probably used to, which is for I is equal to 0, where I is index. I is less than list.size. Okay. List.size. And then we would simply say, hey, if I'm going to actually do this to make it easier for me. So int val, not val, int val is equal to min is equal to list.get. I'm sorry, my brain just seems to be like not in its most optimal position today. Just again, it's been hectic. Int val is equal to list get. Okay, so we get that value out of the list of integer. Okay, and then we say if the val is smaller than the minimum value, then val is equal, then minimum number is equal to that value, right? So if we found something that's smaller than the smallest value, that number is now the smallest value. Likewise, we're just going to do the same thing, but for max. There's no need to do a second for loop. You can just kind of put them in together, right? And remember, these operations over here that the operations I'm currently doing are constant time. The checking to see. Once I get that value out, we're in constant time. Okay, so that's all we need. Now, so the question I am going to ask you is, what is the runtime of this algorithm? Right? That is the next question on this. So what is the runtime of what I just wrote?
Either list and array list or linked list.
That is the correct answer. On has the correct answer. Mm-hmm. Because it depends on what the list is with this implementation. With an array list, this get operation is constant time. With a linked list, this get operation is O of n time. So it is. So as George posted, it is, those are the correct runtimes for those. Now, but this answer also depends on what you write. Because if you write it as a for each loop instead, the for each loop will use the built-in iterator of the linked list, and it will make it so that it's always O of n time. So for int val in list, and all I'm going to do is just simply copy this bit over here. And for this time, and if I ask you what the big O of the runtime for this algorithm is, it's O of n, regardless if it's a linked list or array list. So it really does depend on what you write. I know, trick question, yeah? But just remember, linked lists and array lists do have different runtimes. Okay, so reverse all words. Here again, n is the number of words that we have, so it's the size of the list. So what we're going to do is we're going to write it so it's O of n time again by using the iterator. Using the for each loop. So public list of strings. We're returning a list of strings. And really, this should be static, but I mean, honestly, it doesn't matter. We're right here. Okay, public list string, reverse word string list. So here, given a list of strings, I want my list of string, and we're going to call it, let me move this out of the way. We're going to call this thing new list or ret list. Return list is equal to a new list of string. Don't need to do that bit because diamond notation is magic. Oh, but I need to give it a value. Okay, so over here, it doesn't matter whether you put in an array list or linked list, but don't do what I just did here, right? What is the issue I did here?
Instantiate an interface.
Yep, I can't instantiate an interface. It is a... I'm trying to create a list, but a list doesn't exist. A list is kind of saying I'm a placeholder for any kind of list. You didn't specify the type of list. So because the add method is constant time for both of them, on average, we can go ahead and do either. I'm just going to do linked list because that's what I started typing while I was talking. That's literally the only reason I'm choosing linked list here. For item, so for string word in list, what are we going to do? We need to reverse it and then add it to the return list. So word, so how do I reverse the word? First off, is there an easy built-in function for this guy? No, there is no easy built-in function. If I was working in Python, all I would have to do is do this, but no, Java can't be easy like Python, right? I feel personally attacked here that something so simple does not exist. String reverse is equal to an empty string. We're just going to have to do this the manual way, which is annoying. String. So for each car letter in reverse. Now, why do I use for each all the time? It's because I did a lot of programming in Python. So, and all the for loops in Python are for each loops. But for character letter in the word to character array. So we look for every letter, and then what we're going to do is to reverse it, right? Normally you do something like reversed is equal to reversed plus letter, but that will tack it on to the end, right? In order to reverse it, I need to tack it to the beginning, which is letter press reverse. So add to, so take the letter and add what we currently have for reversed at the end of it. And then don't forget to complete it, we need to take the we've got to take it and add it to the list. Add reversed. If you make a silly mistake like this, right? Oh yeah, you could totally use, if it exists in Java, you can use it. So string builder, yeah, you could totally use string builder in reverse. Just forget that it existed. So if you make a stupid mistake like this, is this an instant fail? No, it's a 1 point mistake. So don't beat yourself up about thinking about making mistakes. I understand what kind of errors can happen when you're coding very quickly. Okay, again, the runtime for this algorithm, because I used the for each loop, is going to be O of n time. Now let's get into the actual meat of our content, these linked list methods. So write a method called delete list, which removes all items in a list, making it empty. So this is going to be mildly annoying because we're going to be here because I'm going to assume I'm working in a linked list here, but I need to actually be inside a linked list but I don't have a linked list on me. So, I mean, I suppose I could, but actually all I need to do is I'll go ahead and just make a silly linked list for me to work with. Just a demo linked list for me to work with for the purposes of this. So I'm going to just call it LL. So I don't do this. Like 10, not too many. I try to keep it short for the online when it's online. So let's go ahead. We've got a linked list, head, tail, and they are doubly linked. Okay. So let's go ahead. Public static class. Or let's go with private static class. Node E. All right. And this is a linked list of E's. Private static node E. And E item. Node E next, node E previous, and node the code will be it will be on Canvas, so you don't need to handwrite anything. You can just type it in on your computer. The only thing you might need to take screenshots or snapshots of are if you draw something or if you have notes you want to upload. Okay, so public node E item, this dot item is equal to item. So here I've just got nodes, which is perfectly fine for me to work with. And now I just need a node. I'd have to have this bit more extensible if I wanted to make sure it was working. But honestly, I don't need to make sure. I don't think. Node E head, node E tail. Okay, I just need it to not yell at me when I'm writing it. Public void delete list. Right, and as an int size is equal to 0. Delete list. All right, so moves all items in a list, making it empty. So now in a singly linked list, all you'd have to really do is remove the head and the tail, set the head and tail equal to null, and it would garbage collect itself. But the issue being here is that because it's doubly linked, everything is kind of pointing to each other. So I think that might not work. So I'll just have to do it manually. So while head not equal to tail. So while the head is not equal to the tail, what are we going to do? We basically say head dot next is equal to, sorry, head is equal to head dot next. This is if we're doing it manually. You could be cheeky and just simply remove, call the remove method and keep calling the remove method on index 0, which is honestly the easier way to do it. So, but I didn't bother writing those, so I'm not going to use them. So right now, so head is equal to head dot next. So that's what I'm going to do. Head is equal to head dot next. And now head dot is kind of the thing that was after head, which means it's still pointing to the thing behind it. So head dot prev is equal to null. And that should take care of that. And then when we're finally at the head and tail there, and that's actually everything we need to do for that, for getting rid of the pointers until we get to head and tail. Then we just simply say head is equal to null, or we simply say head is equal to null. Tail is equal to null. And then most importantly, size is equal to 0, possibly the most important part. Okay. Let's go on to the more interesting problems. Count. Write a method, instance method called count. Count iterates over a linked list and returns the number of times item occurs in the list. All right, instance method. So you can access, so it's very important that you understand that the instance methods, right? You can access head, tail, and node. Would it not just be a valid answer if you set head or tail to null? I'm not sure. You'd at least get partial credit, but I'm not sure that setting head and tail to null anymore would work because right, the head would still have the item in front of it pointing back to it. So there would still be something pointing to it to keep, and I'm not sure if Java's garbage collector is sophisticated enough to know to delete it, or it might just leave it. Right? When the garbage collector only removes stuff when nothing is pointing at it, but the head would still have the thing after it pointing to it. So count. Public int count. Fortunately for this one, we don't really care that's a link, that's a doubly linked list. So we can just use the and then this one int e, or rather e item. Since we're iterating through it, we can just start from the front. Node. So count is equal to 0. Int count is equal to 0. Return count. Or int I is equal to 0. Actually, we don't need a for loop. What we need is a while loop, because when we're working with linked lists, it's always best to do while loops. So while, so node e current is equal to head, while current is not equal to null. Is there anything else we need to know about this? Is it sorted? Does it matter? Nope, just a regular linked list. So while current is not equal to null, so then what we're going to do is we're going to ask, hey, if current dot item dot equals the item I'm looking for, then in that case, count plus plus. Then, so we go through that, check it, increment it. Right. Next thing to do is we would need to advance it. So current. So now current should point to whatever is stored in the memory location of current.next. So we take the memory location stored in current.next, stored in current, and that effectively advances it. And so when we hit null, we're done. Runtime of this is O of n, because we touch each node exactly once, and it takes us constant time to go from one node to the next node. Write a static method that takes two sorted linked lists of integers and merges them into one sorted linked list. So this is the static method outside of linked lists, and you cannot access the node. This is just because because otherwise you're going to be messing with pointers and it's going to be frustrating. You're allowed to you remove items from list A and list B. So, right, I'm going to go ahead and take this and move this to the other class because we're dealing with a linked list and we're not inside linked list. So public static linked list merge, and I'll go ahead and declare these are linked lists as well. Linked list, not that it really matters here. I'm pretty sure I just didn't label them as linked lists on the problem because in the statement just simply so it wouldn't go off the page. So let's go ahead and do linked list of integer. So what we want to do is take these two sorted linked lists and merge them into one sorted linked list. Merged is equal to new linked list. Okay. And we want to do this. Yeah, what is the time complexity? Well, let's see, did I have any restrictions? Well, what I would like to do it is in what's going to be called n plus m time, where if this is n and this is m, right? So if this size is n, this size is m, then we just add those times together. In other words, I'd like to do this in linear time. If they're the same size, I would just simply say O of n. Now, for this argument, I'm going to assume, sorry, for the sake of argument, I'm going to assume that I can move the items around from this list. This would be something if you weren't sure you could do during the exam, go ahead and ask them. If you were just going to go ahead with it anyway, I'd write down that assumption. Because if you're not allowed to remove the items from these lists, these lists have to remain intact. All I would do would I would make new linked lists out of them. There's actually a rather cheeky way to do it, I think, which would simply say list A is equal to new linked list A, which would build a new linked list and store it in list A, and the original list A would still be outside of the method call, whereas now this list A would refer to the new one, which has all the items copied over to it. So the entire point of whether or not we could manipulate list A or list B, in other words, remove items from them, is a moot point because it takes O of n time and 2 lines of code to duplicate them. So, so what I'm going to do is basically, I will take a look at the first, since these things are sorted, that means the smallest item for both of them are going to be at the front, right? And the smallest item needs to go, and the smallest item needs to be the first item in our merged list, right? So, right, if we've got, again, annotate, right? We know these are sorted. So 1, 3, 7, and 2, 5, 9. Right. Suppose these are items. We know that because these are sorted linked lists, that this item over here, that one of these two items needs to be the smallest items, and not only that, but one of those items has to be the first item in our output, specifically the smaller one. So what am I going to do? Well, I'm going to go ahead and I'm going to write my if statement first, and then I'll put in a loop. So if list a dot get 0, constant time operation, is less than list b dot get 0. All right. So those things, if those two things, So this will figure out which one of those is the smaller one. So merge.add list a dot get 0 list a dot then remove. Well, I'll get to that step in a second. Else, right? So if the smaller item is if the smaller item is from A, we're gonna say, hey, A should go in the first location. Otherwise, it should be B. Right. So what do we do next? Well, it turns out that basically, so what would happen here? If we go through this, we could then say this is 1. So 1 is out of the running. So we could just remove it. And then we can repeat the question, right? Because the next smallest item needs to go here. And the next smallest item would be one of the first 2 items. Because the smallest with these things being sorted, the smallest item will always be in the front. So what we're going to do is that we are going to generalize this. So I'm going to switch these 2 gets to removes. And that will remove the index 0. It always defaults to removing the index when it has an integer. And then what do we need to do? Well, then I'll just throw it into a while loop. While list A dot size is greater than 0 and list B dot size is greater than 0. So while they're both greater than 0, while they both still have items in it, we are going to add them to the end of the list. Okay. And now we'll get into the unfortunate position at some point that basically that we would remove all the items from 1, 3, 7, but we would still have 9 left over, or we'd have like 9, 10, 11, 12, 13, 14, 15 left over. We'd have a bunch of items left over. So we need a couple more lines. We need specifically 2 more lines. Which is that this will quit once one of the lists is empty, but we don't know which one. Okay. So to resolve that, what we're going to do is we are going to say merged dot add all. We're going to, and this is just simply a single statement rather than having to deal with a for loop. Add everything from list A. If list A is empty, it's going to add nothing. And same with this one. If list B is empty, it's going to add nothing. Whether it's empty or not really just kind of depends on which one got emptied out first. And we don't have to worry about adding so this will add all the stuff that's from the non-empty one to the end. And from the empty one, when we're adding an empty list, it's like adding 0.
Why will it stop early since it's if list A dot size is greater than 0 and list? Oh, okay.
Yeah,
I got it.
It's and, not or.
Got it.
Yeah, trust me, it takes forever to get. Actually, I don't think anybody ever gets used to and or like, because it also flips depending on whether or not you've got not conditions. It can be very tricky. All right, so the complexity of this algorithm, you can say either it's n plus m, right? That would be the more mathematically correct way of saying it, but I would accept O of n, assuming list A and list B are the same size. It's O of n. It's a linear time algorithm. The more mathematically correct answer, which you wouldn't necessarily have known because we don't really deal too much with A's and we haven't dealt too much with like algorithms that do 2 lists of different sizes, would be, oh, well, the first one is n, the second one is m, so we are moving, we are tackling n items from this one and m items from this one. All right. So next is reversed. So now this is actually a interview question. Could you add both the lists together and then sort them afterwards? I assume that's what you're meaning. Could you use that? Yeah, you could. You could totally do that. But it would take n log n time. So if I'm putting a restriction on, then that would be something that you couldn't necessarily do. So now this next one, reverse, which reverses doubly linked list, is an instance method. So you can use head and tail. That's actually not necessary, but it is a classic interview question saying, hey, if I give you a linked list, could you reverse it? And if you say yes, and you do it doubly linked, they'll say, what about singly linked? And if you're saying, okay, I can do that, and then you use a temporary another list, can you say, can do it in place without using any additional data structures? So this one can get progressively harder depending on what you want to do. I'm just going to go with the brute force method of just doing it as simply as possible. And again, I'm just going to do this. So right here, I'm not going to bother touching the node class. I'm just going to do this as simply as possible. And I'm still going to do it in O of n time because I like simple solutions on exams because it shows me I know that whoever wrote it knows what's going on. So public void reverse, which given a linked list reverses it. Not too bad. And so this would be inside of a linked list. Okay. So this would be inside of a linked list. So annoying, but I have to kind of do it this way. Public Boolean. I'm just going to put in some markers that it won't be able to do anything because of what I'm doing, but public Boolean add, return true. Right, I'm just putting in method stubs so that it will compile. Public Boolean add e item. And then I'll need the other add method, which is let's see, e item. Add void int index e item. That's the other one. And then finally, we need the remove method. Public e remove int index. That's all we need. Again, this code, I'm just writing stubs here so that the code will compile. Although if you try to run it, it's going to crash and burn horribly or hilariously, one of the two. So we've got ourselves a list. We want to reverse it. Easiest way to do that is to create a new list. LLE list temp is equal to new linked list. So what I'm going to do is I'm going to take everything and I'm going to remove it. Wow. Now this dot size is greater than 0. Well, there's items in this linked list. Just move it over. Temp dot add this dot remove. Zero. So that's all we're going to do. We're just going to remove from the end of the list. Sorry, we're going to remove from the beginning of the list and add it. So this basically turns temp. This empties out this list and takes all the contents and puts it in the same order into temp. And now all I have to do to refill the list and reverse it is say, well, temp.size is greater than 0. What we're going to do is say this dot add. And if I did temp.remove, this would add everything in back in the same order. But I want to reverse it. So what I'm going to do is add everything to the head, which takes constant time for each operation. Overall O of n time. So right here, I take the first item, add it to the head. So that would basically, so if I had ABC, I'd take A, and I'd move ABC into temp. And then from temp, I'd say, okay, take A, move it to the beginning of this, which would be A. Then take the B, move it to the beginning of this, which would be BA. Then take the C, move it to the beginning of this list, which would be CBA. So this is a dumb solution, I guess. It is, or a brute force solution. It works. It works in O of n time. It's not particularly elegant, but that's fine. Okay. And part of it is because I want to pass an exam. I want to get this exam done in a good amount of time. I want to have plenty of time. Okay. If the professor meant for me to do something else and said I couldn't do this, then he should have put it there. Okay. So let's go now to the capstone question. All right. Suppose we have a new type of linked list called the sorted linked list. You need to write the add method shown below, which inserts a new item into it in such a way that the list remains sorted. All right, so if we say add 4, it becomes 1, 2, 4, 5. Right, I'm going to assume that even though it says E item, I'm going to go ahead and use integers for this so that will compile my computer a bit easier. And so that I don't have to use the compare to method, right? Right, it says you can use this to compare items. Makes sense. I'm just changing it slightly so that it will compile and look pretty. Okay. So new project. I don't need a new project. I need new class sorted linked list. Let's go ahead and do that. And it's just going to use integers. So no need for that. I'm just going to go ahead and say head and tail over here. I'm going to use a singly linked list. I get to choose them this one. It doesn't tell me whether or not there's a head or tail. I'm going to just keep track. I'll go ahead and keep track of both. Node head, node tail. Now I need to make a node class, which I'll just simply steal from here. And again, I'm just going to make it singly linked list because singly links mean so much less lines of code, literally like 2/3 pretty much. There we go. We've got an item. We've got a next. We've got node class. It takes in an E. Doesn't matter. That is E. Shouldn't matter. I can switch it. So we've got a header and tail. We also need an int size. Int size. That's all I need for this to start programming this. So what we need is now a public void add. So first things first, let's look at kind of the exceptions and basically simpler cases. Okay, so simple cases. Okay, so I want to add a number int item to this list. Okay, I want to add this item to the list. This item is a number. And this has a couple cases. So first off, let's go ahead and compare this to our the homework. the homework's first case, that first thing we had to check for was out of bounds. Does that matter here? Is out of bounds applicable here? Yes or no? No, right? We don't need to make an out of bounds check here, right? Because we're not getting an index. We're giving it an item, and the sorted linked list is just supposed to figure them out. Okay, let's look at other cases. All right, so one of the things we have to care about, the big thing we have to care about with the cases for linked lists is if we're whenever we're adding or removing items, we got to ask ourselves, are we changing whatever the head or tail is? Okay, that's actually not too hard to do here. First off, if it's bigger, if it's smaller than the smallest item in the list, then so this is sorted linked list. So if we're at, say we've got this, I'll have this over here. Sorry. So rules, right? Can't use add index item, can't use the get node method, although if you can rewrite it. This is just simply saying you don't need it. And we want to run it in O of n time. Because if you wrote the get node time, it wouldn't run in O of n time. Because you'd spend all your time trying to call the item. So, okay. So suppose we have this list, 1, 2, 4, 5. If we add any number that's less than 1, that number is going to become the new head. If we add any number that's greater than 5, that number is going to become the new tail. So let's go ahead and take care of those. Okay. If item is less than head.item, right? E item, right? So that's just an issue over there with that. So go ahead and turn it into an int item, and we'll just simply get rid of these because, again, we're just going for speed here, and it's perfectly fine. Okay, so public void add int item. If item is less than the item stored in the head, congratulations. Actually, I'm going to go ahead and say less than or equal to make my life easier. So if I've got an item that's smaller than or equal to the current item stored in the head, congratulations. This is super easy to do because all I'm doing is adding a new head. Node. Let's go. I'm going to have to make a new node here anyway. So node adding is equal to new node item. So I'll just do that. So I don't have to repeat it a bunch of times. Adding dot next is equal to head. Head. Now this adding becomes the new head. Head is equal to adding, right? And all I'm going to do over here, and then I'm going to just do size plus plus at the end so I don't forget about it. Do you fail the exam if you forget about size plus plus? No, you're going to lose a point. That's all. Again, right? Minor mistakes that are like one line like that that don't really impact what I'm testing you on aren't going to really matter. Exam battle, linked list exam battle royale edition. All right. Similarly, if item, and this is only if you care about the tail, which I'm going to do here because I haven't in previous years. If tail.item, so if the new item we're adding is greater than the item that's stored in the tail, because we have access to the tail, right? This is actually, again, a constant. This is a constant time operation. This is a constant time operation. Tail, what we're going to do is say tail.next is equal to adding. We're going to attach the new item. And then tail is equal to adding. All right, so that will attach that. So again, with the greater than or equal to, this whole gets rid of this annoying conditions where we might have other issues. Issues with like, well, if we try to insert it before the small, well, if we try to insert the new 5, like a new 5 before a 5 or otherwise. So if it's not the head or the tail, it's something in the middle. We got to put somewhere in the middle, which means we need to start iterating over it. So also I'm going to turn this into an else if so that I don't accidentally trigger multiple statements. So this should only, we're going to limit ourselves here. Only going to be working if if we're inserting in the middle of the list. So what we need to do is start manually going through the list. So node current is equal to head. Node, and what we're going to do is say while current is not equal to tail, right? If we get all the way up to tail, once we get up to tail, we can stop, or we can just actually, wait a sec. Although you might not make that conclusion. When you're working on an exam, sometimes if you've got to do a while loop like this, it's just easier to do while true. And then whenever you do whatever you need to do, just break out, right? Use the break statement. Who doesn't know what the break statement does? Because it's a fairly useful statement. So for those of you so for use of so what a break statement does is that it breaks out of the current innermost loop it's in. So it destroys the loop that it's currently in. And it will only destroy a single layer of a loop. So basically it's saying, stop the loop. We're done here. No need to go on. So it will help you exit out of a while true loop. That's it. It breaks a loop or breaks you out of a loop, depending on how you want to look at it. Okay. So while true, what we're going to do is we're going to say, okay, we're currently here on this item. So let's generalize this out inside this loop, right? Because all we're doing is defining that starting point. You know, I say I'm going to know where my pen is, but I immediately knock it off my desk onto my floor. And there we go. Oh, come on. After all that work of picking it up with my feet. So annotate. So here, right, let's go ahead and draw this because drawing is very useful in these kind of situations. So here I am on current, and there's some amount of nodes. Here's adding, right? And current.next like that. And there's some other nodes. And every time we advance, and it doesn't really matter if these are only 3 nodes we care about, current, current.next, and adding. So what we can do is basically say, okay, because we've already checked head, we know that when we're at current, we're not going to be less than it. So what we can do is basically say, hey, if adding is less than whatever's current.next, we can just attach this over here and then make current point to this. So like, for instance, say that this is, we've got 7 and 12 and I'm adding 10. Okay. What I could do here is basically say, okay, is adding less than current.next? Is adding less than current.next? And it is. So what we'll do is we'll say adding.next is equal to current.next, and then current.next is equal to adding, and then everybody's happy. On the other hand, like what if we're in this situation, 7, 8, right? We'll say, okay, is adding less than current.next item? No, so we're just going to go on to the next item. So we would say 8 here, and then we'd look at the next thing, and that would be 9, and then we'd look onto the next thing, and so on. Is everybody following what my strategy is? So current So we're going to need to advance this. Current is equal to current.next at some point. We'll do that at the end though. So I'm just putting that there so I don't forget about it. Okay. And so now what we're going to do is simply say, hey, if if item is less than or equal to current dot next dot item. If the item we're looking at is less than the next item, that means we should go between these items that I'm currently at. Item current is less than or equal to current. So we would just simply say, hey, adding dot next is equal to current dot next. Current dot next is equal to adding, and that attaches them. And that attaches our new node in. And then to empty it out, and then to stop, we'll just simply say break. And that will just destroy the while loop when we're in. We'll exit out of the, so we'll exit out, we're done with the else statement, and we're done. So that's how you can add that. Everybody follow that?
And you don't have to check if you know that it's either greater than the, you know when you get to the while true part, it's not less than the smallest or greater than the biggest in the list.
Right. And because we checked our first item and current starts out as the first item in the list, it kind of allows us to do like this nice proof by induction where we never have to check, hey, is it also bigger than current? We never have to check that. Mm-hmm. If you do check that, that's no problem whatsoever. Also, you don't have to worry about it being null because it's got to be in between. It's got to fit somewhere in the list. If current.next is tail, it's going to fit before tail. It's not going to fit after tail because you would have already checked if it should have fit after tail. Make sense? All right. All right. Last part of this exam, the analysis, which will also be it should be the second to last question on the exam. The very last question on the exam is a 0-point question where you'll be able to upload any source code / pictures or whatever that you're just worried that won't get, you know, if you want to upload anything such as copies, local copies of your code, because you're worried that the text box won't keep it, then that's what the last question will be. But the actual last question, real question is, this is analysis. A list can be implemented in a number of ways. Compare and contrast an array list and a linked list. In which situations would you implement a list over another? So let's consider this. So there's 3 big ways that they differ from each other, right? First off, you've got your methods, your paired methods together. You've got your add and remove, right? The paired add and removes. So they differ in how add and removing from the list work. And they also differ in how get and set work. Okay, so those are 2 different categories there. But the first thing we'll talk about is the memory usage, right? They use memory in different ways, right? So an array list uses memory by basically saying, okay, I'm about to kind of break your conception of the way array lists are, right? An array list, you might think that an array list of numbers, array list of strings, right? It's not actually going to store a bunch of strings in it, right? This isn't going to store apple, banana, carrot, durian. It's not actually going to store those words. It will store references to those words. So that's kind of a moot point there. But essentially that's how it's going to work. Now, on the other hand, but basically this will store a pointer. Now, how much memory does a pointer take up? Does it matter? No, because everything we're going to look at as pointers, but I think it takes up 32 bits. It might be 32 or 64. I can't remember for Java. So what are we going to do over? So on the other hand, a linked list, each node takes up, each node has the following attributes. It has the pointer to the item, and then it has a pointer to the next item, as well as possibly the previous, depending. Okay. So an array list uses basically just stores a pointer to the item, right, in each of these slots. But for each of the slots, the nodes for the array, for the linked list, you're storing the item as well as the pointer to the next, as well as the previous. So if you have a array list and a linked list with the same size, right? With the same size, if they're the same size, then the linked list is going to have up to 3 times the amount of overhead, right? This additional cost in memory cost. Does that make sense to everybody? Right, for each item in an array list, you're just storing where it is. For a linked list, you're storing where you can find that item in the computer, as well as what the next node is and what the previous node is. So obviously, linked lists are the inferior option here. Except, right, what am I missing about array list? What is the disadvantage of an array list?
Reallocating?
Reallocating, right? Suppose I've got a million item, I've got a size 1 million array list, and I've got a size 1 million capacity. If I need to store 1 million and 1 items, I need to reallocate, which will involve me doubling the capacity of the list, right? So we now go from 1 million to 2 million. And now I add my million and first item. So suddenly I have 999,999 wasted slots of null. So array lists can waste memory via reallocation. Although I should point out that there's a very useful method for array lists that runs in O of n time, which is just simply called trim. And what that does is that it simply shrinks the array list so that the capacity matches the size. So if you're really, so you'll only temporarily waste memory then. So if you really care about memory, then you want to get as close to an array as possible. Make sense? Because arrays, you know exactly how much you're going to be using and you can't change them. Array lists are like, I want to be able to change the size of those, and I'm willing to deal with wasting some space to account for that. Linked lists, completely different. Linked lists are when we really don't care about when linked lists are great when you want to take things apart and split them up and rearrange items in a list all willy-nilly. But so overall for the memory, there's a lot of different options. Give me 1 sec. I'm going to see if I can't find my write-up on my computer. So, and this should be, actually, let me go ahead and grab the file, and I'll just send this out as an announcement. I'll send this out as an announcement later. So, oh, I didn't write it out there. Interesting. Okay. So with array lists and linked lists, it really just depends on the way. They both waste memories in different way. Array lists can waste memory in the fact that you can waste memory via reallocating, and you can have a bunch of empty spaces. Whereas a linked list, you can waste memory. You waste memory just by having it exist, by having extra overhead. to keep track of where the next and where the next items are. What about add and remove, right? Let's look at the easier case right now. So adding to a linked list. So let's add to a linked list here. If we're adding to a linked list, it's constant time all the time if you're adding to the header tail, right? Adding a new item to beginning or end of a linked list, constant time always. Otherwise, it's O of n time because you got to look for the item and then you got to add in the item. So O of n time there. On the other hand, if you are running a linked list, sorry, on the other hand, for an array list, it is, let's see, it's always O of n time to add to an array list, except when?
At the end.
At the end. Except when?
You're reallocating.
Except when you reallocate. So it's O of n except when you add to the end, except when you're reallocating. So with that one, I'd say if I'm just trying to add nodes to a linked to a list, and I'm doing a lot of add operations, and that's all I care about, definitely use a linked list. There's just more scenarios where it's going to be where adding is quicker. And adding to the end and the beginning are the most common places you add to a linked list. You're adding to a linked list, or sorry, to any list. Finally, get and set. What is the get and set runtime for a linked list?
O of n.
Right, it takes O of n time to find something in a linked list. Doesn't matter where it is. Well, of course, if it's at the beginning or end, that's constant, but honestly, that's not really that important. What about a get and set in the array list? How long does get and set take? Yep. George says constant. It is constant time to get and set in the array list. That is correct. So if you're trying to, and there's no exceptions to this, no weird exceptions to this. If you are getting and setting in an array list, that's what you want to do. Array lists are great if you have specific indices you want to retrieve and specific indices you want to replace. So get and set, by far the superior option is an array list. All right. So that is my so those are the answers to this. Honestly, if I look at my PDF, it's mostly empty because a lot of times it said just refer to what you're doing in class. So yeah, it's an older version. So here I've gone over the exam. Are there any questions before we are done with now I'm going to double check. Now that I'm not sharing my screen, I am going to actually double check what's on the exam, what I have currently written. So questions before class ends.
The exam will be mainly on singly linked list.
Yeah.
Mhm.
Exam 1. And be sure to watch the videos on, start watching videos on recursion if you haven't yet. So that recursion will be this week and next week. So let's see. So let me see what the questions are. First question is a drawing question. So yeah, the first couple questions, I have you, instead of having you do the whole step, writing the steps out of what are the steps to do, I ask you to draw steps. So draw things. So then you have one question on the on dealing with a linked on a general list, like from exam, like from the second homework. 2 linked list questions, and then yeah, there's only 7 questions on this exam. And then you have 2 questions on dealing with sorted linked lists.
Are those sorted linked list questions the 2 linked list questions, or are they 2 and 2? Oh, they're the same?
Yep. The linked list questions are going to be sorted linked list questions. Okay, so have fun with that.
The exam answers still are locked
Right.
on Canvas. Are you gonna? lock them
No, I can't. I looked at the practice exam and it's an old practice exam. It's not.
Oh, okay.
You can take the same liberties for the sorted linked list question. Mhm. Singly. Focus on singly linked lists.
Can we assume the singly linked lists, or do they have a tail, or we can't?